Hey fellow YouTubers, this is N0AGI. I'm here to do the part 3 of the APRS protocol based remote device control project. You must have seen my other two parts, and if not, please do go watch them just to get some quick context on the project itself. So what I'm here to do is the next part of that project, and really what this is about is showing you a fully working example. This has everything in it except for the 110 volt device plugged into this. So that part is not done yet, but really in principle this is a fully working example, and I'll talk to you and show you this working fairly quickly here. So just to give you a quick lay of the land, there is the user radio, the site radio. The site radio is hooked up to the tnc-pi that rides on top of this Raspberry Pi 3. And then the tnc-pi extends the Raspberry Pi 3's GPIO pins over here. And then there's the relay that is hooked up to the Raspberry Pi, and I'll walk you through that. And then the other end of the relay is hooked up to this green LED, okay, with I believe it's a 1K or 100R resistor. But anyway, so that's a quick lay of the land. Just to quickly walk you through how this relay is hooked up. I mean, if you could watch a ton of videos on YouTube, but let me quickly cover how this works and how easy it is to make this work. I got this relay board with the control mechanism all baked into the single board off of eBay. I think I got 5 of them off of eBay. I'll make sure I put a link to that on my description. So really, this board has two sections to this. This one here and this one here. This section here is what controls the relay itself, meaning the power supply going to the relay, the 5 volt supply, and this gray colored cable, jumper cable, is what controls the turning on and off the relay. Okay, and this section of the relay contains or needs a 5 volt input and a ground, and they are supplied by the Raspberry Pi's onboard GPIO pins. Okay, and it might be hard to look at it here, but let me pull up the pinout diagram. Okay, so if you look at this section here, that there are two 5 volt outputs. So the Raspberry Pi's, rather the relay's 5 volt supply is connected up to that pin, and then the ground is connected up to that pin. Now this guy here, the gray colored jumper cable that controls the relay itself from the Raspberry Pi, that pin is one of the GPIO pins that goes up and down or high or low, and depending on what signal you send to that GPIO pin, the relay either turns itself on or off. Okay, and that GPIO pin, I have used GPIO pin 26. Okay, it's as simple as that. Now, so that's this section of the relay. This other section of the relay is what controls the LED, or in real life, it'll control the repeater or any 110 volt device, so to speak. Okay, in my example, that is. And obviously, the LED requires a positive and a negative. The ground for LED is hooked up to this ground here on the GPIO pins, the GPIO board or the pinout. And the 5 volt, for now, in real life, this won't be hooked up this way, because what we are talking in real life is a 110 volt, and you will see another version of that video as my part 4. But in this example, this 5 volt comes out of one of the pins on the board, and that would be one of these guys. Okay, All right, so that's a quick context. And as I noted in my previous video, the LED is hooked up to the relay in a normally closed or NC mode, which means that when the relay is off because the this green LED is not lit, so the relay itself is off. I'm trying to get this thing to autofocus and it's not working, unfortunately. Okay, so the green LED is not lit up, so the relay is off. When the relay is off, I want this LED to be on. So it's normally closed, like I described in my previous video. Okay. But when the relay is on, the power is cut out for the LED, and the LED turns itself off. Okay. But by default, we want the LED to be on, just like we would like for the repeater to be on all the time. Okay. All right. So that covers the simple circuit hookup point of view. Now let's go on to the process flow, just to do a quick refresh. There is a KISS protocol service that runs on the Raspberry Pi as a background process. And then there is the AX Listen service that is also running in the background on the Raspberry Pi. And I'll show you that on my laptop here fairly quick. And then there is a Python app that I wrote that uses the AX Listen and other AX tools to control this whole, or to orchestrate this whole workflow that's running on the Raspberry Pi. And I'll show you that also. So here's a quick flow of the process flow. User, let's say me, will use this radio N0AGI-8 to send off a message, not an APRS status or a position or MIC, etc., but I'm going to send an APRS message type of a APRS type of a message type of a message, if you know what I mean, to over RF. And this guy, or this the tnc-pi is configured to be as N0AGI-4. Okay. And when I send off this message, this radio, which sits in the site, will receive that message. tnc-pi will unpack it or intercept it, send it off to the Raspberry Pi. The Python application in the Raspberry Pi will parse it, figure out what to do, and then either turns on or off the relay, and that's it, really. The process is fairly straightforward. So that's a quick summary. So let's go over to my laptop and I'll show you how this works. Okay, so let's try this one more time. And what I'm trying to do is I'll probably show you this demo in two types of visual. The first visual would be to use my FT1D, and then just to show you what's going on the application front on the screen. So let me pull up a quick simple example. I'm going to send it off to N0AGI-4, and the message is nothing but CMD. Again, at this point in time, the message is not that important. I'm just going to send a message to it and see how it responds. So I'm going to hit enter. For now, just watch the screen and look at the responses from the app, and I'll show you on the other side how each of those devices work. And then let me do that as my visual number 2. For visual 1, let's just start with this one. So as you can tell, it says N0AGI-4 command, and 07 is the ID of the command. It says message received. Sending an acknowledgement back to this device. This guy will receive an acknowledgement, an AM message, acknowledge message, and then followed by that, the application recycles the relay and Here, let me actually show you this way. Okay, let me start with this. Receives a message. It sends an acknowledgement back to the sender, an AM message, followed by it does a recycle, a relay recycle, meaning power on, power off recycle. It waits for about 10 seconds in this example, turns on the relay, which means turns off the device, and then waits another 10 seconds or so to turn back off the relay and turn back the device on. And then before it leaves, it cleans up the GPIOs and then sends off a message back to the sender, N0AGI-8, that the command was completed, and then goes back into the waiting mode. What you're seeing here is the acknowledgement from N0AGI-8, this guy here, back to the Raspberry Pi, that it received a done command, done message as an acknowledgement back. So I hope that's kind of clear. So it's nothing complicated. It's fairly straightforward. I just got a bunch of these messages just for my debugging purposes, but really what's going on behind the scenes is very, very straightforward and very simple. Now, I'm going to do the same thing. So just keep this in mind as we walk through here to see how this thing works, okay? And I'm trying to see if I can capture it all together in one shot here. So keep in mind the LED's on, it's always on, and I'm going to send this message now again. Okay, that's the acknowledgement message back from the Raspberry Pi. And we'll wait. And there the relay is turned on. The LED, green LED lights, and the device is off. This LED is off. And now it waits another few seconds. It goes back on again. And the Yaesu should receive an acknowledgement back that it is completed. So as you can see, the done message here with the acknowledgement back. All right, so that's it really. So let's try this one more time. And I'm gonna go back to the message. Let's see if I can delete the pre-existing ones. Okay, I'm gonna send again. Don't worry about the message itself. I'm not doing anything special with the message for now. I'm gonna just send a message. Acknowledgement back. AM. Relay turns on. There you go. Waits a few more seconds. Turns it back on. There you go. And then we should receive a done message back. And now that the last send that this radio sent out, that's the acknowledgement message from here back to the Raspberry Pi or the site node. Hope that was not as painful to watch, but I think that kind of captures the workflow. If you have any questions, let me know. I'll try to post the code as much as I can onto my blog. Please do visit the blog, and I'll post the simple circuit diagram, etc. in there. And then once, my next step will be to hook up a 110 volt device to the business end of by replacing this LED with the real 110 volt application or device, and then come back and do another quick demo. So I hope that was useful. Actually, let me show you the code really quick. Because, oh, by the way, one other thing, this is kind of interesting. I wanted to show, I included a command in there for quitting. Again, nothing fancy. Let's do I think it was, for now, it was QQQ. All right, let's hit send and just watch that. Okay, let's watch that. I'm going to hit send now. Okay, a quit command received, quitting. So again, this won't be in real production. I just wanted to show you how this can be controlled really well, because over the air, you're able to use APRS as the protocol, as the underlying protocol, with tnc-pi as the Raspberry Pi based TNC, and to control over the air devices and behavior of endpoint devices. I think it's very fascinating. Anyways, if you have any questions, please do drop me a note or provide any feedback. Would be good to hear. We'll talk soon. And oh, by the way, I need to show you still. I need to show you still the, as promised, some code here. All right, so very simple. Let me move up the code base. Raspberry Pi's GPIO, just get that in, time and OS. For now, just ignore these functions here, and I'll come to that briefly. What's happening here? Let me pull up. Okay, so this is where the business starts. Quick message on the screen. I've configured the AX-listen command to dump its output into a log file, and then my Python app picks up the log file and receives a last line item in the log file, and then parses that. Of course, in my end product, the way I parse it and what I look for in the message, etc., will differ, but just for the purposes of this demonstration, what I'm doing is I'm looking for the sender's call sign. I have two endpoints that I'm trying to use. In this case, I showed you N0AGI-8. Look for the from call sign, parse out the from and the to, and then look for the data, and look for the message, whether this data was of message type, and that's a prefix for the message type. Figure out the, oh yeah, now that we can say we got a message from the sender, do a quick recycle of the relay, wait for some more seconds, and then turn the relay back off. So as you can tell, I'm not doing any special messaging or message parsing of the actual message for this demo. I'm just receiving the message from N0AGI-8 and recycling the relay. Okay. And then when there's a quit command, I'm basically issuing a quit from the loop. There are a couple of commands, functions I've written here. Let's go back up here. Let's look at the send acknowledge. It uses the beacon shell command. That's part of the AX tools to send the message back to the sender. The command is beacon. Use the os.system API to call the shell command. And this is the other similar beacon, but instead of ACK message, I'm just sending back a done message with an ID. Okay. Make sure when you send the ACK back that you use the same ID that it was received, that was received by the application, because an ACK has to be attached to a pre-sent ID message. Otherwise, it's really not an ACK. Okay. All right. So let's go back up here. What's in the power recycle? In the cycle relay, I'm saying, hey, I'm wait for 10 seconds, relay on, device off, which is right above here, basically pin number 26. Set up the GPIO APIs, set up the output to high, send off a high message, which will then turn on the relay and turn off the device. right? And then come back down here, wait for another 10 seconds, and clean up the GPIO. When you clean up the GPIO, it returns the status back to where it was. In this case, it's normally closed. That's it. Nothing fancy going on. All right? I'll try to post this message or the code in my blog. Please do keep an eye out for it. And thanks for watching. We'll talk soon.